This is problem 8-40 from section 8.1.2. It says consider the graphs of the following types of functions. Which functions are polynomial functions? Explain your reasoning. Alright, so let's think about an example maybe for each of these. It would be helpful. A parabola, the parent function for a parabola is normally y equals x squared. Now let's think about what is a polynomial function, first of all. That is written as y equals any number times x to the whole number power, which means 0, 1, 2, 3, and so on. It cannot be negative, and it cannot be like decimals, fractions like that. They have to be whole numbers which start from 0. Okay, so let's think, does this equation, does this parent function y equals x squared satisfy this? Yes, the number in front of here would be a 1. X to the whole number power, 2 is a whole number, yes, that would be a polynomial function because of the equation. If you need to explain it, I'd have your equation written down and say that it satisfies this definition right here. Exponential is y equals a times b to the x, where a is a number, b is a number, and x is just x. Now x is not the exponent down here for polynomials, so exponential equations are not polynomials because the exponent is not allowed to be the variable for polynomials. Okay? Cubics, y equals the parent function of that would be y equals x to the third power. Well, it's basically the same thing as parabolas, except it has a third as my power instead of a second. Okay, so that one's going to be a yes. Think about a line. The basic equation of a line would be, well, mx plus b is the most basic thing of that, but if I put numbers in here, y equals x is the equation of a line. Okay? So a number, there's a 1 in the front, would be my number part, times x raised to the whole number power. That could be an x to the first power. So a line, yes, is a polynomial. It might not be a crazy polynomial, but it satisfies the definition. Circle. Think x squared plus y squared equals r squared. Now in this definition right here, it says y equals this stuff. Okay? Now if I do solve this equation, we have to type this in before to our calculator, but when we do that, we end up having y equals the square root of all this stuff, x squared, blah, 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 and then y equals negative square root of this stuff. And we have talked about many times in class, you cannot just actually take the square root of this stuff. You can't do that because then it's not a circle anymore. Okay? You can't just say the square root of it. If I square this side to get rid of the square root side, I'm back at where I started. So a circle is not going to be a polynomial because I cannot get the y by itself and have x to the whole number power. It would have a square root in it, so I can't do that. If it was, there was a question on the other night's homework, it said, was y equals, it had a square root of x in there. That's not allowed either. So square roots, which are included in the circles, are not polynomials, and exponential functions are also not polynomial functions.